ask you to find the answer to x plus 2 quantity squared, you'd probably really have no problem doing it because you've learned the method FOIL or you know how to distribute. But what if I ask you to find the problem to x plus 2 quantity to the 7th power to the 8th power? That would mean you'd have to multiply two of the factors together, and then you'd have to multiply again, and it would really be a huge pain. So I'm going to show you a little bit easier way to do that using something that's called Pascal's triangle. At the end of this lesson, you'll be able to use Pascal's triangle to expand binomial expressions. All right, first of all, just to get us ready for using Pascal's triangle, if I'm looking at the expressions below, it says to name the coefficients in the expanded binomial expressions. You'll notice if I have x plus 1 to the first power, the expansion is just x plus y if I were to work the problem out. If you recall, coefficients are just the numbers in front of the expansion. So if I have nothing in front of there, they'd just be 1. So my coefficients are 1 and 1. You'll notice then if I have x plus 1 to the second power, if we were to distribute that out, remember that would just mean x plus y times x plus y, we would get x squared plus 2xy plus y squared. And again, I'm going to put 1s where there's nothing there. And if you look at our coefficients, again, the numbers in front of the variables, we've got 1, 2, 1. All right, if we have x plus y to the third power, I'd actually have to do x plus y times x plus y times x plus y. And if I worked that all out, even though it's going to be a little bit tedious, I would end up with the expression given right there. And again, I'm going to put 1s where there's nothing. And so if I list my coefficients, I'm going to have 1, 3, 3, 1. All right. Now look at the first 7 rows of Pascal's triangle. This is just a triangle that someone with the last name of Pascal discovered. And if you look at them, hopefully you're noticing that in the first expression, our expansion was 1, 1. In our second expansion, our coefficients were 1, 2, 1. In our next expression, our coefficients were 1, 3, 3, 1. So notice there definitely is a pattern forming. I'd also like to, as long as we're on the Pascal triangle screen, just a few little things. Notice we've got 1s always going along on the outside. We can follow diagonally, 1, 2, 3, 4, 5, 6. And kind of one really cool thing, if you look at, if I have 1 and 1, and now notice right down below it, we've got 2. So 1 plus 1 is 2. Notice here, 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6. So always the 2 on top of it, if you add them together, will give you the term below it. So if you ever want terms for Pascal's triangle down here, since I didn't give them to you, it would be real easy to create them. Okay, back to the subject though. How are the coefficients of the binomial expressions related to Pascal's triangle? I kind of already talked about that accidentally. So if we look at that again, we've got we just did it, so I'm just going to not worry about this slide. The next thing is what happens to the x term in each expansion. So if you'll notice here, this doesn't really do anything for us. We've just got x and y. And one thing, notice the expansion was to the first power, and we used 1 and 1. And so notice this is kind of, we're going to call this row 0. This would be row 1, row 2, row 3, row 4, row 5, row 6. So notice if I was in row 1, that's where my coefficients came from. Notice if it's to the second power, we're going to look at row 2, and my coefficients were 1, 2, and 1. And then if I look at the x term in each expansion on this one, notice starting with my x was my first term, it started out being to the second power, and then to the first power, and then it disappeared, so really it would be like it was to the 0 power. And then it also says, and then let's just keep doing that. If I look at this next one, we have x to the third, then x to the second, and then x to the first, and then again my x drops out, so it would be like it was to the 0 power. And now let's look at what's happening to the y term, to that second term. If we're going backwards, if we start at the other side of the expression, notice we're going y to the second, y to the first, and then the y drops out. And then in this next one, we had to a third power. Starting at the right, we had y to the third, y to the second, y to the first, and then it dropped out. So can we use this to actually expand binomial expressions? You bet. All right, so we actually are going to try to use Pascal's triangle here to expand the following binomial expressions. Notice we have x plus y to the fourth power, and I'm going to go ahead and label my rows here. Okay, so if it's to the fourth power, we're going to be in row 4. So the first thing that I'm going to do, I know that my coefficients are going to look just like that. So I'm going to have 1, 4, 6, 4, 1. The next thing that I know is going to be happening is we are going to have an x, and it's going to start at the highest power. So I'm going to have x to the 4, and then it's just going to decrease x to the 3, x to the 2, x, and then it drops out. And then we're going to have, starting with y to the 4th, going the other way. So we'll have y to the 4th, y to the 3rd, y to the 2nd, y, and then the y drops out. Now for the signs, since there's a plus sign here, every single time I do multiply, I will be getting a positive answer if I were to actually expand that out. So I can just put plus signs in between each term, and then we would be all set. So that would be the expansion for x plus y to the 4th power. Okay, looking at part B, if I have x plus 1 to the 5th power, what we're going to do this time is we're going to look at row 5 for our coefficients. We're going to have 1, 5, 10, 10, 5, 1. And then again, we're going to start at the left side with the x, and the highest power will be 5. So x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x, and then it drops out for that last one. And then starting from the other side, notice we have a number instead of a variable. So we'll just put, I'm going to put it in parentheses, 1 to the 5th, 1 to the 4th, 1 to the 3rd, 1 to the 2nd, 1 to the 1st, and then it drops out. And since again this number is positive, we're just going to get to put plus signs in between each term. And then if I actually were to simplify that out, didn't give myself enough room here, but that's all right. Okay, 1x to the 5 is just x to the 5, and then plus 1 times that 5 is just 5, x to the 4, and then plus 1 squared is 1, times that 10 is still just 10, x to the 3rd, plus 1 to the 3rd is 1, times that 10 is 10, 10x squared, plus 1 to the 4th is 1, times 5 is 5x, and then plus 1 to the 5th is 1, times 1 is 1. So that would be that expression expanded. And notice, instead of taking that 5 times, I do believe that that was much, much faster if you can get the pattern down. All right, the next one I noticed that it's a binomial expression to the 3rd power, so I get to use row 3 of Pascal's triangle. 1, 3, 3, 1, and then starting with this first term, we've got an x, and we'll start it to the 3rd power. So x cubed, x squared, x, and then it's going to drop out. And then going the other way, this time I'm actually going to take negative 3 with me on each one. So we're going to start it with negative 3 to the 3rd power, negative 3 to the 2nd power, negative 3 to the 1st power, and then we've got nothing. I'm going to put plus signs right now in between the expressions. And now simplifying it, 1x to the 3rd is just x to the 3rd. And then here, negative 3 to the 1st is negative 3 times the 3 that's already sitting out front is going to give me a negative 9x squared. And then here, a negative 3 to the 2nd power is going to be 9 times the 3 that's already sitting out there is going to be a positive 27, so positive 27x. And then here, negative 3 to the 3rd power is negative 27 times the one that's already sitting out there is going to be minus 27. So that would be the binomial expansion for this specific problem. This does only work if you have a binomial expression, which there's only 2 terms inside of the parentheses, but hopefully you now know how to use Pascal's triangle to expand binomial expressions.